What's up, math fans? Today I want to solve using quadratic techniques. Quadratic techniques, well, here are my quadratic techniques. You've already learned how to solve quadratic equations, I hope. And you learned a bunch of different methods, but basically here's a quadratic equation in standard form, and here's the quadratic formula. Not quadratic equation. This one's the quadratic formula. This is a quadratic equation, okay? So if you have it in standard form, you can plug it in here in this equation and you will always get a solution, or usually two solutions. But I actually prefer factoring, and the different methods of factoring all out there on video. I can use dots, I can use the sum product method, but I actually prefer, always look for a GCF. Not that I prefer, you should always look for a GCF first. Alright, so here's a quadratic equation. I know it's quadratic because the highest exponent is 2. I'm going to look for a GCF, there is none, so I'm going to go to sum product. Here's the sum product method. It's basically the reverse of FOIL. If you remember FOIL, first, outer, inner, last, it's really just multiplying. So basically you're asking, what do you multiply together to give me that? I definitely need x times x to give me x squared, and then I need two factors of 36 that will also add to 13, negative 13. So the sum of the numbers have to be negative 13, the product have to be 36. 6 and 6 won't work. 36 and 1 won't work. 12 and 3 won't work, so we're going to go with 9 and 4. Minus 9, negative 9 and minus or negative 4. This will definitely multiply to 36 and add to negative 13. And then we do something called the t-chart, because if this term times this term multiply to give me 0, by the zero product property, either the first term equals 0 or the second term equals 0. And then it's a one-step equation, so I'm going to add 9 to both sides, and I get my solution, 9. Alright, add 4 to both sides, and I'll get my solution of positive 4. If you want to check your work, you take the 9, one at a time here. 9, plug it in here and here, and see if that works out to 0. It will. Do the same thing with 4, and it will. Now, this can represent a graph. Instead of equals 0, if it said equals y or equals f of x, and you type that in a calculator, a graphing calculator, this will give you a quadratic function. What does a quadratic function look like? A parabola. It should look something like this. And these are called the roots. They're also called the zeros. They're also called the solutions. Boom, solutions. So this number, this point is 9, and this one is 4. So if you solve algebraically, it's the same as finding the roots graphically. All right? Here, if you saw my video on how to evaluate higher degree functions, you'll know that if it's a 4th degree function, you're looking for 4. You're looking for 4 roots. And you should be expecting 4. Let's see here. You should be expecting 1, 2, 3, 4 x-intercepts, or 4 zeros, or 4 solutions, or 4 roots, okay? And it is possible that this one swings good, but then that one kind of curls up there. This is still a 4th degree, so you're expecting up to 4. You might not get all 4, you might get only 2, and then 2 imaginary roots. But let's find out. We'll do it algebraically. But this says using quadratic techniques. This isn't a quadratic. How am I supposed to do that? You have to recognize something. And it doesn't always work, but in these examples, of course, it will work. This is actually something squared. X to the 4th is really x squared, okay? That's x to the 4th. So now I can just do what I did. X squared times x squared will give me x to the 4th, all right? And I still need the minus 9 and the minus 4. Now what's cool about this is a difference of 2 squares, dots. Remember how to factor that? 3 times 3 is 9, and here, plus 2 minus 2. So instead of a t-chart like I had in the last one, it's like a super duper t-chart with 4 things going in. So either this equals 0, or this equals 0, or this equals 0, or this equals 0. So I'm going to solve all 4, and you should get x equals negative 3, or x equals 3, or x equals negative 2, or x equals 2. 4 solutions. So the graph actually would look like that, and these 4 values are these 4 zeros. Solutions, x-intercepts, roots, whatever word you want to use. All right? So that's how this matches the graph. Let's go last one. Fraction. Oh no, I'm scared. Don't be scared yet. If they give you a fraction, there's a good chance that that fraction is really something squared. So you got to recognize that x to the 2/3 is really x to the 1/3 squared, because you multiply powers when you raise a power to a power. So when I factor, I'm going to have x to the 1/3 times x to the 1/3. And if you'll notice in all my examples, all three examples, this was your clue. This thing squared gives you that thing. This variable with that exponent gives you this variable with that exponent. So it works out perfectly. And here I need a -5 and a -1. You didn't have too many choices when you factored 5. And now I go to my t-chart. Either this thing equals 0 or this thing equals 0. Oh no, a fraction, I'm scared. Do what you know. What do you know? One step to try to isolate the variable, but the variable is not isolated because I need a power of 1 here and I have a power of 1/3. So if you saw my video on rational exponents, how to get rid of a 1/3, you raise it to the reciprocal power. The reciprocal of 1/3 is 3. So I have to raise both sides to the 3rd power. The 3's and the 1/3 will cancel. X is now alone. 5 to the 3rd is 5 times 5 times 5 is 25 times 5 is 125. So there's one root, which would be way too big for me to graph. I wouldn't see that on the window. I'd really have to keep zooming out. Or we add 1 here to both sides. X to the 1/3 equals 1. Again, you raise both sides to the 3rd power, the reciprocal of the exponent. They will cancel, and x equals 1 times 1 times 1 is not 3, it's still 1. So there are your 2 solutions, okay? So I know it's kind of confusing because you're expecting 2/3 of a solution, but no, this is actually a quadratic in disguise, and we have 2 solutions, all right? By the way, I would definitely do the check to make sure they both work. Thanks for watching. See ya.